Hi, this is Russ Anderson. In this second part of our incident analysis tutorial, we're ready to start working on the plane itself. As you may recall from the introduction, tracking the plane is going to involve supervised tracking also. So here, we're going to be wanting to track different features on the plane. Now to keep those trackers separate from the ones on the camera, we go over here to the Shot menu and say Add Moving Object. You'll see now there's another active tracker host that is going to be this plane. So the new trackers that we create are going to be associated with the plane. So we can go and start adding them in and tracking them through the shot. And again, as with the ones before, we need to keep an eye on them. Make sure that they come out nice and stable, and sooner or later, as it starts to go off the edge, or turn the end on, at some point you need to start adjusting it and eventually shutting it off. So here we're going to be looking for a lot of different positions on the plane that are distributed throughout the plane. And in this particular shot, you'll see that some of them go off the edge of the screen there, and it gets to be a little more challenging as the plane gets further away. So I am going to go and work on that, and I will be right back with magically many more supervised trackers. Now I've completed the tracking. You can see one individual tracker here, the setup that I was using, and you'll notice that as described in the supervised tracking masterclass, I'm using bidirectional blending here, and there's fairly frequent keying on this because it's changing around to such a great extent over the course of the shot. And not all the trackers extend through the entire length of the shot. Let's just give an overall look. You can see there are trackers all around, and I've emphasized trying to get trackers out on the ends of things far away from the center of the object, because those far out trackers are the ones that give you information about the orientation of the vehicle. If everything's all tight in towards the middle, you don't really get any information about where the wings are, what the attitude of the aircraft is here. And you see then we get a different set of trackers towards the latter part of the shot where you get a different view. So in fact, these trackers out here were all tracked in reverse, starting from this view at the very end, running backwards until they go back out of the field of view in that particular direction. So you can go and look at the overall coverage, and you can see I have coverage throughout the shot. You've got our tracker count here, in the low teens throughout the shot. So at this point, we could actually go and do a solve of this scene just based on those trackers without using the 3D model. And the reason that would work is because the object goes through such a change in attitude here that we get to look at it from a bunch of different directions to be able to triangulate basically where everything has gone. But if we were only given this portion of the shot where it's traveling straight ahead, we wouldn't be able to do that kind of triangulation. And that's why we need the 3D model as a reference so that we can accommodate cases where the vehicle of whatever kind really isn't moving all that much or changing in attitude that much. We're ready to start using our 3D model. We want our 3D model to correspond exactly to the vehicle that we're tracking. So for example, if we're tracking a stretch model of a plane in the imagery, we need to have a 3D model with that stretch version of the plane. If you try to use a different model than what you're tracking, it's not going to turn out right. So let's start off by going to the 3D room, and we'll switch to a quad perspective view. And we'll bring in our mesh. So it's going to be down here at the origin. And you'll notice we've got this marker here that's Object 01. And you may recall that's what's up here is the tracker host that our trackers have been created on, the trackers that are on the plane itself. So this is the null for the plane itself. It's going to be animated ultimately. Right now the plane is sitting there, and because we imported the plane when this was selected, the plane is parented to that Object 01 null. So we need to do a couple of adjustments here. We'll start off by bringing in the texture map for that. We want it to be a lit texture. We don't want the red color necessarily to be causing issues. So let's just move back. There are a couple different ways to do the 3D navigation and Synthize here. I'm just showing one that makes it as clear as possible as to what we're doing. So you can move things around. There's our plane. It's kind of generally lit without any real lights in the scene. We also want to turn on back faces. That's an issue with some parts of this model. And here in the perspective window, we're going to go and we're going to create smooth normal, so that eliminates the faceting, and it also makes it render faster, as it turns out. So here's our plane. So next we're going to make a couple of adjustments in the positioning relative to that object null. The first thing that we're going to do is apply a scaling to it, and I'm going to put in a little magic fudge factor to it, if you like, which is necessary to make the units come out. So if you've gotten your mesh from a third-party source, especially, you need to verify that you have the right units. You want to be coming up and have the model be in the same physical units as the scene that you're working in. So you might need to rescale your model exactly to match the units that you're working on. You can actually use Synthia to do that with the help of a couple of trackers on it. If you need to actually do some measurement on the plane, I don't know, from the wingspan, say, to do that, or you might be able to use the reference information on the model and what you're doing to adjust the scaling. Here I've just used this value that's come in via other means. So we're going to go and we'll spin the plane around in the right direction. I think a more kind of useful direction. And let's just zoom in here. And we'll bring it up a little bit. And I'm going to hold down the control key as I do this, because the scaling of this value there is determined by the world size, and in this case the world size is quite large, so the step size is nominally high, but using the control key that just cuts it down. And in the side view here, let's just go and bring the wheels down so that they're on the ground. So you notice that we've got the null sitting there basically at ground level. The plane is sitting up above it. So now when we do the tracking, the null should be sitting around at the same ground level. So that gives us an easy cross-check as to how we're doing in our overall tracking process, how accurately it has gone. So that's just a useful setup for it. Our next task is to show Synthize where each of the trackers should be on the 3D model of the plane. So I'm going to show you the most accurate way to do that. I'll just point out that it is possible to make the mesh line up with the image and then put all the trackers onto the mesh directly in one fell swoop. That's generally not going to be the most accurate way though, so I'm going to show you the most accurate way to do so. So we're going to go over to the geometric hierarchy view where we can see what we're going to be working on easily. So we've got here our trackers. Let's just adjust our views a bit, and we're going to change this one to be the camera view. So what we're going to be doing is finding the trackers in the camera view, seeing where they are on the plane, and then making them, putting them onto the 3D model in the corresponding location. So to do that, we use this mode called Place on Mesh, and we're just going to select a tracker, and now we can just go. I'm going to use a bunch of 2D zooms in the perspective view to help do this. So we just put it right onto there. You saw there's a little flag that shows the relative normal direction off of the mesh as well, and kind of gives you another view of where it is. So having done one, now we can just use the down arrow to go on to the next tracker. It's sitting up here on the top of the tail. So we can go and put that roughly into the right spot. You'll see it disappears when it's not on it at all. But it's here. Let me just right click to get out of that. So I'm going to orbit around that particular spot. I'm going to zoom back in. So you can just do a little fine tuning. And I'll point out, if you hold down the Shift key, then it snaps onto the nearest vertex. So that can help make things easier and more accurate as well. So I'm just going to work through this here, see how this goes. And while I do that, I will put you on pause. Now you can see that I've completed this task. I've got all the trackers positioned on the plane. You can see them all there. And of course in the different views. So, I did find it easiest eventually just to use the dolly in and out. So I just dolly in on some particular area, put the marker there, dolly back out, and then just drop the tracker onto somewhere in the general vicinity of the right spot, and then dolly in on that spot again, because when you dolly in, it does concentrate on whatever it is that you've already got selected. So that did go along reasonably quickly, but it does take a little time. You got a bunch of trackers involved. We're now ready to solve for the path of the plane. Now usually we're going to have better information for the camera solve, because it's based on nice surveyed information and stuff, compared to the solve that we're going to get from the object. A lot of times the object is really small in the field of view of the camera, and it may not actually change that much in orientation. So to compensate for that, it's generally a good idea to lock up the solve from the camera so that it's not affected by the object solve. Normally, if you solve them both at once, the two are combined to get the best overall solve. Here we're going to probably say, let's stick with what we've got for the camera. So I've just told it we want to stick with that field of view that we got for the camera's lens. And now we'll go to the camera, and instead of having it solved, we're going to just disable it. So it's going to stay with the same solve positions and orientation trajectories that we've already got. So now let's take a look back at the object. We're going to go with a from seed point solve for that, since we have gone and put those out there so nicely. One little technical thing we need to do is just select all of our trackers, and assuming that they're all of equally high quality, we'll make them all seed points that'll get used initially. So I'll get back to the solver panel, and we're ready to solve. So now we have our initial solution, and we can scrub through it, and you can see that the plane is now completely covered by the model that we've got. So that's looking pretty good. Now, it's always important to go and take a look after you've done the solve, at the real details of what's going on. So I'm here in the graph editor, and the error curve here is the difference between the 2D and the 3D locations of the point in the image. So this is in pixels. And you can see we've got one that has a kind of alarmingly high error to it. So, we can use this isolate tool just to go and select just that one. And, it's going to this fantastically high value up here, 20 pixels and stuff. So that's really pretty bad. And so, after you've done the solve, you want to go and see what's going on. What's the reason for that? So let's go. I'm going to go back to our tracker panel, and I'm going to hit pan to follow and just scrub through the shot. And let's also go and we'll just hide the plain mesh model for the moment. So we scrub through this thing. Need to get our tracker 30 back. And you can see it stays on the same pylon. That looks good. Certainly here there would be a risk that maybe I'd accidentally started tracking one of the incorrect pylons. So that's not what's going on. But if you look, you'll see that here's the seed point sitting off here in the middle of the air. And so that's clearly a problem. So really what's going on is that I put the tracker point on this pylon or fuel pod or whatever it is out there instead of this one. So that's what we need to go and fix. So we can hop back and let's see, maybe we'll just let's see where we've got this thing now. Where we've got it is turned off, so that would make it difficult. So the problem is the seed point's sitting out on that pylon there. It needs to be on that one. So we'll just go to the place mode. We've got that tracker selected. We'll move it over to the correct one. Just dolly in a little there and orbit. So now we've got it positioned better. And now, of course, we're going to go back and we're just going to rerun the solve. Now you see that we have a much, much lower error. Now we can go and repeat and do the same thing and hit Control A again. See, it looks like this one still is not the world's hottest. So let's see what's going on with that one. That's on the tail of the plane. That's our pan to follow 5 key there. So really the likely story here is probably we'd be better off not doing this tracking back here at all for this latter part of the shot, just because that back elevator has both a front and a back to it. So probably what's happening is that for part of the shot, we're creeping up further forward on that elevator, and that's why the error is so high on that. So we could probably try and go and correct that if we wanted to, and maybe if we had a little better look at it On some real imaging, there might be a bit more contrast to it than this synthetic imagery. So back here in the solver view, again, we can scrub through the shot, and you can see just a little bit of fringing here, some that are the differences between the mesh model position and the actual image of the plane. So that's giving you a reasonable look at how it's all gone. So from this particular data, once you've got the solve for the aircraft, now you can go also to the graph editor and go up to the object, and now, what people are often interested in, here's some velocity data for it. So this is showing, what it's getting. And these are frame by frame differences. We still need to get rid of that one. So we have the different individual values here, and you can export this data for crash analysis purposes as plain text files, columns of numbers that you can process further. So, this is velocity data that's just the difference between each frame and the previous one. And you can also go and get, of course, just the plain positional data and work from that. So, in all cases, you want to be taking a careful look at the results of the solve here and make sure that there aren't things that are incorrect, that are causing biases in your results. Another cross-check that I had mentioned involved this. The position of that null, and the claim was that since it is at the at the bottom level of the plane, that we do want it to come out at ground level. And you can see that that's pretty true. And off in the distance, it goes up a little bit further. And, that may in fact be real. That might be the fact that the airport probably isn't super exactly flat. So, you want to be taking a look at all the data carefully and proving out that it's right before you rely on that for crash analysis. Another technique for doing that is to add additional points at this stage onto the vehicle, and rather than resolving them, you can have them be zero-weighted trackers. I invite you to look that up in the manual, which just lets you add in additional points that aren't being used as part of the solve. So you can see if you add some other point in some other part of the plane, how well does that come out? That without having the solve be based on that particular point. So again, it's a cross-check on what you're doing. Looking at the velocity curves here, you may want to have those filtered out a bit for analysis purposes. So SynthEyes does have the tool for doing that. Over here on the solver panel, there's this path filtering control. And this can be used to apply filtering either on a one-shot basis, like immediately, or after each solve if you've set it up initially. So just to give you an idea, if we want to just filter out a couple of these axes, we can just enable those. There's frequency controls and a strength control, and those can actually be animated over the course of the shot. So you can do a little more filtering in some sections and less in other. And the risk of doing the filtering, I'll point out, is that you actually cause sliding. You actually cause mismatches between the position of the 3D model and where it is in the scene. That's because SynthEyes is already telling you what the best possible solution is. So if you go and filter it, you're actually making things a bit worse. But so we can go and do some filtering like this, and of course just really smooth things out quite a lot. We can do the other axes for that matter as well. So There are a bunch of options here. There we do everything. But you do create additional small mismatches depending on how much filtering you do. You can reduce the frequency even further and smooth things out more and create more sliding, or filter less. So that's up to you. It's ultimately an artistic decision and a question of what you need and what makes sense in the particular environment. So you do have to use a little control, but it's there for you. So I hope this gives you some look at all the different things that are involved in doing this kind of crash analysis process. It's not a one button thing by a long shot, but you can work through this and get some really nice data. So thanks for watching.